Um, Hi, good evening, everyone. This is Sowndarya Mam. So, I hope everyone are doing good, right? Yeah, my voice clear. I guess my voice is clear. Hello, let me check. Yes. Okay. So, hi, hello, good evening. So, if you are watching this video, just give me the quick about yourself. So, this session is for who are preparing for PU2. So today we're going to discuss about continuity and differentiability. So I hope my voice is clear. Okay. So if you are watching this video, just put your comments in comment box. Okay. This is our first session in mathematics. So before jumping into this session, I just wanted to introduce myself. So today my voice is little bad. Guys, I just okay. So yeah, this is Sowndarya Ravichandran. I have 6+ years of teaching experience in mathematics. So in KCET, this topic is actually one of the very important topic. One of my favorite topic also I can say. Most students will say that calculus what is easy to solve, understand. Today we are going to discuss continuity and differentiability concept. I hope most of the students who are in PU2 already aware of what is continuity. So, and also you know about limits. So without knowing limits, we can't understand continuity. Okay. So limits is what basic here. Okay. So we will see what is continuity in this session. Without wasting time, we will move on to today's lot. Okay. So yeah, what is continuity? Suppose f is the function. So f is a real function on the subset of real numbers. And let C be the point on the domain. So what does mean by function first of all? So what does mean by function? Wait a sec. So hi, good evening. So 1 minute. Oh my god. Why can't write? Give me a sec, students. Okay. I don't know what is. Give me a sec. Okay, I think something. There is a problem in my pen tab, I guess. It's okay. Let me sort it out within a minute. Fine, fine. Okay, so let me tell you what is continuity. So, have you discussed this before in classroom? Yeah. So, have you ever discussed, do you know this topic continuity? So, if you know, just tell me what you know about it. Suppose f is a function. So, f is a function which is on the subset of real numbers. So, the range of f is nothing but the subset of real numbers. Let C be a random point on the domain. So, then f is continuous at C. So, what is meant by continuous? A function is said to be continuous if it is defined in all the values of domain without any break. So, there is no such break or jump or hole in the function. If these three are valid, then I can say the function is continuous. So, how can I check whether the function is continuous at a particular point C? At a particular point C. How can I say that? I don't know what happened to my. Give me a sec. Okay, guys, sorry for the delay. Sorry for the delay. Okay. I guess now it's fine, right? So can you hear me, guys? First of all, tell me that. Can you hear me? So we will start from the beginning. So can you hear me? Okay, okay, fine. So now it's fine, right? Okay. So let us proceed with the content now. So we will start from the beginning. Continuity and differentiability is one of the important topic in KCET. Okay. So actually it's one of the easy topic also if you understand it clearly. So what is continuity? So when I have a graph like this, when I have a, okay. So when I have a graph like this, so let me take y is equal to f of x. It looks like a continuous graph. Why it is continuous? Since the graph has no break point. So there is no break, right? So there is no hole in it. So the function is defined in this domain. So I consider the domain value as a to b. Okay. So in this particular domain, if you see, the function is very smooth and also it is continuous. There is no breakpoint, there is no hole, and it is continuous in the particular domain, right? So this is how you see continuity. If the graph is given, it is easy that we can say it is continuous or not by looking at the graph behavior. But when the question like y is equal to f of x function is given to you, how to figure out it is continuous? Suppose f is a function, real function. Real function means what? It is a subset of real number. And let's see be the point in the domain of this function. So then f is continuous at C if limit. So f is said to be continuous. F is said to be continuous. So f y is equal to f of x. This function is said to be continuous at x is equal to c. So let me take a point in the domain real. Okay. So let me consider the function f from real to real. Okay. So y is equal to f of x at x is equal to c. Is it defined? Yeah, I can find f of c is equal to some value in y. So this y I can take as L. So L. So if you look at the limit x approaching to c f of x. So you already aware of what is the limit. When the limit exists, when the limit will exist. So the limit will exist when LHL and RHL are equal. So LHL is left hand limit and RHL is right hand limit. So according to this graph, what is LHL? So the LHL when x value is approaching to C from left side, which means x takes value which is less than C. I can say C minus H, where H is very small value. Where H is very small value, so which is greater than 0. So with this condition, I can say C minus H is less than C, right? So the LHL is LHL. So you can write limit x approaching to C minus f of x. So that is nothing but limit h approaches to 0, f of C minus h. X is taking the value which is less than C. So that is C minus h. I hope you understood how to find LHL. So these things you already aware of. Am I right? So PU1, you know what is limit is. Okay, what is limit? RHL, what is RHL? Right hand limit. It takes value which is greater than C. That is nothing but C plus H. So the limit RHL is nothing but, you can write this as limit x approaches to C plus. So this notation is for RHL. So when you want to write in terms of H, so you can write H approaches to 0, F of C plus H. C plus H for right hand limit, C minus H for left hand limit. So if these two limits are equal, LHL, RHL are equal, I can say the limit exists. So what is the condition here? So what is the condition here? So let me erase everything. So look. So in simple, I can say F is continuous at x is equal to C when the limit x approaching to C f of x actually equal to function at C. If these two are equal, I can say the limit, I can say that function is continuous at x is equal to C. Okay. So this is for particular point C. If I want to say the function f is continuous, so f is continuous at the domain D. So then what is the condition? For all x, for all a belongs to domain, I can say limit x approaching to a, f of x is equal to f of a. So if you want to say f is continuous at the domain D, so each and every value in the domain. So let me take a. So that is a, each and every value on the domain D. The limit x approaching to a, f of x is equal to f of a. If this is true, then I can say the function is continuous at the domain D. So I hope you understood, somewhat you got what is continuous, right? So if the function is continuous, there is no break, there is no jump, there is no hole. Okay, so keep that in mind. So now we are going to discuss a problem. Discuss the continuity of the function f given by f of x is equal to modulus x. So you know what is modulus function. So what is modulus function first of all? I hope everyone aware of what is modulus function. So what is mod x? So what is mod x? Mod x is equal to, so when x, so mod only give value, positive value. Mod will give only positive value, which means if x is less than or equal to 0, so it is negative, x value is negative. So in order to make it positive, it multiplies minus, so minus x. So if x is positive, so then it is x only, no? So there is no difference. So modulus of x is equal to, when x is negative, minus x, when x is positive, it is plus x. So how to draw the graph? X, y. So when x is positive, it is y is equal to x graph. When x is negative, it is y is equal to minus x graph. This is y is equal to mod x. So looking at the graph, I can clearly say that there is no jump, there is no breakpoint. The function is continuous. How I can say that it is continuous? So there are three cases. So case 1, here when x is less than 0, okay, when x is less than 0, I am going to consider the value of a if a belongs to minus infinity to 0. Okay, so that particular value of a is less than this. So limit x approaching to a f of x. So the limit x approaches to a. So since a is less than 0, so which condition it will take? Minus x. So f of x is minus x. Since x is negative here, right? So if x is negative, it will take minus x. So you want to put minus x here. So you will be getting limit x approaching to a. So here the value will be minus a. Right? Fine. So what is f of a? Since a is negative, the function is minus x. So it is minus a. So I can say that limit x approaching to a, f of x is equal to f of a. So here the function is continuous if x is less than 0. Similarly, you can prove for x is greater than 0. If x is greater than 0, so the limit x approaching to a, f of x is equal to limit x approaching to a. So since x is positive, it will take x. So you will get x. I hope this is clear, right? So it is x, which is equal to, so x can be replaced with a. So what about f of a? So f of a, since a is positive quantity, x is the function, so you will be getting a only. So here also I can say that limit at f of a is same, so it is continuous. So coming to, so x is less than 0, it is continuous. X is greater than 0, it is continuous. So you want to check with the value, the break point 0. At x is equal to 0, whether it is continuous or not, you need to check. Okay. Actually, you no need to put this also because it is very obvious. So when x is less than or equal to 0, I can say it is minus x. So minus x is nothing but a straight line, right? It is continuous in this particular interval. So it's just for the understanding since we are solving first question. So I told you that this is continuous when x is less than 0. So at x is equal to 0, what will happen? We will look. So give me a sec. So let me erase this. So till this, are you kind of get it, guys? Just if you are watching, put it in the comment box whether it is clear for you or not. So at x is equal to 0. So at this particular point, we need to check. Why we need to check in this particular point? So if you see the function, take different values at left and right side of 0. Right? So at 0, if you see. So left side, the value less than 0. It will take, the function takes minus x. So if x is greater than 0, it takes positive value. Since it is the break point, so you wanted to find out, in order to check whether limit x approaching to 0 f of x. So this exists or not, you need to check. Since it is break point, So you want to check for LHL and RHL. Left hand limit, right hand limit. Why? Because left side of 0 takes one different value. Right side of 0 take another different function. Right? So take another function. So because of that, we want to do LHL and RHL. So why, Hemant, you want me to stop? LHL, the limit x approaching to 0 minus f of x. That is nothing but, since x value takes value less than 0, f of x will be replaced by minus x. Limit x approaches to 0 minus. So what is f of x? That is minus x. So which is equal to 0. So you want to substitute x is equal to 0 here, right? So when x is equal to 0, minus 0 is nothing but 0. When limit x approaches to 0 plus, so we are doing for RHL, f of x. So here x value takes more than 0, greater than 0. So the f of x function will be replaced by x only. So x is equal to 0 here. So both LHL and RHL are same. LHL, RHL are equal. I can see the limit exists. Limit x approaching to 0 to f of x exists. Limit x approaching to 0, f of x is equal to f of 0 or not, I need to check. When we put x is equal to 0 in this function, so you will get 0 only, no? So f of 0, it is equal. So I can say that the function is continuous. So you look at the graph, it is continuous. So it is easy. Since it is first question, we solve this much steps. I hope you understood how to check or discuss continuity of the function. Right? Is it clear for you guys? Okay. So now we are going to, so I've taken some of your book questions and also KCET previous year questions. So let's solve little fast from now. So I hope continuity you are clear. So try to solve this question. Look, here when x is not equal to 0, x to the function takes x power 3 plus 3, right? So we wanted to check whether the function is continuous or not. Here they asking us to show that the function is not continuous at x is equal to 0. So in order to check whether the function is continuous or not, limit x approaching to 0 f of x. So you need to find first. So the limit x approaching to 0. So since left and right side of value x is equal to 0 takes this function. So you no need to check for LHL and RHL. You can directly replace f of x by x to the power 3 plus 3. So the limit x approaching to 0. So f of x you want to replace by x to the power 3 plus 3. So now substitute x is equal to 0 here. So you will be getting 3 only, no? So the limit x approaching to 0, f of x is equal to 3 for this case. Right? Okay. So coming to f of 0 value. What is f of 0? So what is PW? Hemant? F of 0 is equal to what? 1. It's a very clear result. F of 0 is 1. So but according to my continuous definition, if f is continuous, at x is equal to a or some value, so the limit x approaching to a f of x must be equal to f of a. So according to this result, so this condition, limit x approaching to 0, f of x is actually 3, but f of 0 is actually 1. These two are not equal. So I can say that f is not continuous at x is equal to 0. That's it. Okay. So now it makes sense, right? Got it? Right. So next question we can discuss. Oh, so are you listening or want to put comments, Hemant? So which grade you are from? So discuss the continuity of the function f defined by f of x is equal to 1 by x. So this question you need to approach with a little care. Why? Because at x is equal to 0, this function is not defined. The function is not defined. The function is not defined at x is equal to 0. So in the domain, we don't have x is equal to 0. So f of x is equal to 1 by x, where x is not equal to 0. So you want to discuss the continuity of the function, whether the function is continuous in the domain. So we are not including x is equal to 0 here. Okay. Okay, fine. So let's try to understand whether the function is continuous or not. Okay. So let me take value of x, which is less than 0. Or like we can take any value of x belongs to this. So when I take x value, case 1, x is less than 0. So the limit x approaching to a. So where here a belongs to minus infinity comma 0. Okay. So f of x. Or we can take value, 1 minute. So wait a sec. So instead of taking case 1 and case 2, we can directly use like here x belongs to real value except 0. Okay. So let me take a value belongs to this domain. So which is equal to limit x approaching to a 1 by x. So f of x can be replaced by 1 by x. So now if you look at this, so what I get? Limit. So directly substitute a value. So I can surely say that a is not equal to 0, right? So 1 by a. So this value is defined. So the limit, there is no restriction. Similarly, f of a is nothing but 1 by a. So I can clearly say that limit x approaching to a f of x and f of a are equal. If these two are equal, I can say that the function is continuous at x is equal to f is continuous at x is equal to a. Okay. So where a belongs to all real except 0. Okay. So for this particular question, I need to give you another one input. So which is at 0. So at 0, I can say the function cannot be defined. So what is the behavior of the function in the neighborhood of 0? So let's discuss that. That is an additional information. Give me a sec. So for this question, so this is the answer. So this one I wanted to show you guys. So if you are listening, if you are having any doubts, you can drop your comments in comment box. So better comment properly, na? Discuss the continuity of the function. F. So here the continuity part done. So I'm going to tell you the behavior of the function in the neighborhood of x. So let me take limit x approaching to 0 minus. So left hand limit. Okay. So the values, if you see, x is approaching to 0 minus. If I wanted to write it in terms of limit, x approaches to, like, I will change to h. H approaches to 0. So then this x can be replaced by, so the value of x is less than 0. So if I introduce x, a positive value, which is greater than 0, so then 1 by x can be replaced by 0 minus h. This is left hand limit. So I can write, so when this approaches to minus 1 by h. So the limit h approaches to 0. So the h is very small, right? So then in denominator you may get 0.00001. So 1 by 0.001 will become something big, infinite, right? So here you have minus in front. So you will be getting minus infinite. So what about limit? Limit h approaches to 0 plus 1 by x. When I have h approaches to 0, 1 divided by 0 plus h. So the limit h approaches to 0, 1 by h, which is equal to 1 divided by. So here also h value is approaching to 0. So very close to 0. 0.0001. Denominator you have very small quantity. Reciprocal is nothing but very big quantity. So that is infinity. So I can write infinity here. So LHL, RHL are different. So which is not equal. I can say limit doesn't exist. So the limit doesn't exist here. Okay. So with this, I can draw the graph with this information. So 1 by x graph, you already aware of it, right? Look. So look at the graph. So this is y is equal to 1 by x graph. Am I right? So with this information, you try to understand. So here was, so the x value is approaching to 0 minus. So when it approaches to 0 minus, here if you see, the graph is approaching minus infinity. So when x is approaching to 0 from positive side, so if you look, the graph is approaching plus infinity. Since this particular function cannot be defined, so here y is equal to 1 by x, no. So what is x is equal to 1 by y? So at y is equal to 0, x cannot be defined. X cannot be defined. So that is why at y is equal to 0. So you have this. Okay. So when we discuss in future, we will be discussing about asymptotes. So that time I will be giving you a better clarity about the session. So actually this is my first session for you guys. So I'm also little nervous initially. So, and also my pent up didn't work properly. I got tensed. So, and I feel like I get the continuity now, right? So I hope you guys understood this question. I thought of bringing you to so many questions, but I wanted to make this session much clear. I wanted to make basics clear. So that is why I have taken most questions from your book. Okay. So, and I have some interesting questions from KCET previous year questions. So we will discuss that also in the session. Look at this question. Find all the points of discontinuity of the function. So what does mean by discontinuity? So wherever the function having jump or break point or hole, so that is called as point of discontinuity. So that you need to check. So whenever you have a piecewise function or stepwise function like this. What you want to do? So what do you want to do? 1 minute. So what do you want to do? Limit, if you see, so x is equals to, here the breakpoint is 1. So f of 1 is actually equals to 0. So I don't know about the limit x approaching to 1 f of x. So that we need to find. And other points if you look. So when x is less than 1, okay, so the function f of x is nothing but x plus 2. The function f is continuous, obviously. Continuous when x is less than 1. Since it is linear function, x is less than 1. So here it is 1. When x is less than 1, what function it takes? X plus 2. So that is y is equal to x plus 2. So when x is equal to 0, y value is 2. When y is equal to 0, x is equal to minus 2. The graph something looks like this. Okay. So at x is equal to 1, you will be getting 3. Okay. So the graph. So at x is equal to 1. So here you have a hole. So why I have hole here? So here it is given less than 1 only. It is not equal to. So at x is equal to 1, we have the function y is equal to 0. So at x is equal to 1, y is equals to 0. So you want to put a point here. So then x is greater than 1. If x is greater than 1, y is equal to x minus 2. So y is equal to x minus 2. When y is equal to 0, x will be 2. Okay. When y is equal to 0, x is equal to 2. Okay. So then when x is equal to 0, it is minus 2. It will be like this. Okay. So the graph, 1 minute. The graph looks like this. Okay. So here also you have goal. So you can relate this, right? So when x is less than 1, we have a function y is equal to x plus 2. When x is equal to 1, we have y is equal to 0. When x is equal to 2, so when x is equal to 1, here I have minus 1. Okay. So when x is greater than 1, it will have the function value as x minus 2. Got it? So this is the graph. Seeing the graph itself, you can clearly say that there is jump. So 3 is at x is equal to 1, you have point of discontinuous. The point of discontinuity of the function is x is equal to 1. Okay. So how can I prove it theoretically? So the limit x approaches to 1, f of x need to find. So here it is stepwise function and the breakpoint is also 1. So you want to look for HL, RHL and LHL. So what is RHL? Limit x approaching to 1 minus. Yes, there will be live daily, no different subject. So mathematics, in a week you will be having 1 class. Okay. Limit x approaches to 1 minus 1 plus. So here it is right hand limit 1 plus f of x. Since you have 1 plus, okay, since you have 1 plus, so the value of x is greater than 1. So that is x minus 2. The function value will be replaced by x minus 1, x minus 2. So when x is equal to 1, what is the value? 1 minus 2 is minus 1. So here RHL is equal to minus 1. Similarly, I'm going to find limit x approaching to 1 minus. So since 1 minus means what? The value of x is less than 1. So which condition? The function takes x plus 2 as the value, which is equal to limit x approaches to 1 minus x plus 2. So when I substitute x is equal to 1 here, so you will be getting 3. So 3 is the LHL. So here LHL and RHL are not equal. So since LHL, RHL are not equal, I can say that the function is discontinuous at x is equal to 1. The function is not continuous at x is equal to 1. So also I can say that the point of discontinuity is x is equal to 1. Getting my point? So they're asking about all discontinuous point. I find only one discontinuous point in the domain, whole domain. Got it? Yes. So let's move on to the next question. Okay. Okay. So find all the points of discontinuous of the greatest integer function. 1 minute. Find all points of discontinuity of the greatest integer function defined by. I hope you guys know about greatest integer function. F of x is equal to greatest integer function of x. What it means? So the output of this function, no, it is only integer. So the output of the function is nothing but integer. Okay. So according to the definition of greatest integer function, I will tell you the simple definition. So when you have x value as 1.1, so the value of this greatest integer, what integer it will give? So 1.1. So you have to think in this way. What is the greatest integer less than this particular number? Greatest integer less than this number is 1 only, no? So 1. So the greatest integer which is less than this will be 1 only. So what is 3.5? So the greatest integer less than 3.5 will be 3. Okay. So this is what greatest integer function. So most of the students get confused in if you have negative number in it. So for example, if I have negative number minus 3.9. So you want to think the greatest number less than this. So what is less than 3.9? The integer which is less than 3.9. Greatest integer less than 3.9 is what? Minus 4. So you are supposed to write minus 4, not minus 3, minus 2. Okay. So keep that in mind. So now I am going to tell you the graph of this. So these additional information will give you the idea, basic idea. Okay. So let me draw a function. So here, so if you see, so how can I draw greatest integer function? So let me start from 0 to 1 interval. So 0 to 1, you will be getting 0.1, 0.2. The value between 0 to 1 will be 0. If that x input takes value between 0 to 1, the output, the integer value, what integer value greatest integer function give? 0 only, no? 0. So when it is equal to 1, so it will come to 1. So then 1 to, till it reach 2, it will be between this 1 only. So 1 to 2, you get 1 only. So when it comes to 2, so it shift to 2. 2 will be the output. 2 to 3. So it is 3 only. So 3 it will reach to 3 and the function will go like this. So here it's minus 1. So here it is minus 1. Here you find whole. So minus 2. So if it is minus 2, here you find whole. So this is how you draw y is equal to greatest integer function of x. So now find all points of discontinuity of the function of the greatest integer function is the definition. If I see the graph, I can clearly say that whenever the function is not an integer, then there is no issue. The function is continuous. Whenever you have a fraction or decimal number, it is continuous. Rational or irrational, apart from integer, it is continuous. When the function is in at integer point, so left side it takes another value, right side it takes different value, right? So at integer, the function is discontinuous, right? How can I say this? How can I prove it? So when x value, x belongs to any real except integer, if I have this, okay, so the limit x approaches to a. So here I can clearly say that a belongs to r minus z. Okay, so now this x approaching to a, this a particular number is not an integer. I am sure about it. So that is any value in between integers. So then what is f of x? So that will be giving you the value. So like limit x approaching to a. So I will be getting greatest integer function of x. Okay, so that is greatest integer function of a. So whatever the value a, so you will be getting that value only. So I can also say that f of a is nothing but greatest integer function of a. So you can simply write like this. This can be understood. And okay, so now I can say in this particular interval, the function is continuous. But when x value belongs to integer, limit x approaching to a. So here a is belonging to integer means. So here is the problem. So you want to look at the right and left hand limit, right? So the right hand limit, if you see, the value will be less than that. For example, if I have 2, okay, limit x particular thing is approaching to 2. So the greatest integer function. So I wanted to look at LHL and RHL. So what is LHL here? Limit x approaches to 2 minus. So greatest integer function of x. So x value is taking value less than 2. So less than 2 means 1.9 something. So the value is 1 here. So when I come RHL, so it is 2 plus. So it will be taking value more than 2. So which is 2. Getting my point? So LHL and RHL are different. So the limit does not exist. Since limit is not existing, I can say that it is continuous. Right? So that is why it is continuous. It is not continuous at integer. So the all points of discontinuity, set of all integers is the answer for the question. I hope you understood. Hi. So kindly put your name in the chat box, whoever listening the session, and tell me which grade you are in, what topic in your school they are taking. Okay, so whether you can understand my teaching or not, just text it in the, just put your comments in the comment box. Okay, so now we came to a question which is from KCET. Okay, so look at this question. The function represented by the following graph is, okay, this. Okay guys, you can clearly see that this graph is what? So this particular line, look, So this particular line I can easily say. So what it is? When y is equal to x plus 1, x minus 1, sorry. Y is equal to x minus 1. Okay, so this is the function. Here, this is y is equal to, since it is decreasing, minus x plus 1. Okay, so from the graph, I can write this. How I am writing this? So you know x-intercept, right? So what is x-intercept here? X-intercept is 1. So since y is equal to okay. Okay. So y is equal to x minus 1. Y is equal to, in this particular case, it is x minus plus 1. So if x is greater than 1, if x is lesser than or equal to 1. That's the case. Oh, if I write here, you can't see, I guess. Okay. Fine. So what can be done? So let's solve this. So they asking you to check whether the function is continuous. Differentiability I didn't teach you, right? So I'll come to that differentiability part. Before that, you check whether the function is continuous. In this function, I can see clearly that everywhere the function is actually continuous. There is no breakpoint, right? So there is no jump. I can say the function is continuous, right? So the limit x approaching to 1, f of x, if you see here the value is actually 0. F of 1 is also equal to 0. That's it. Okay. So the function is continuous. The function is continuous at x is equal to 0. Okay. Fine. I don't know how many of you are watching this session. But if the session is interactive, then it is much more interesting. I feel like I am the only one teaching here. So, okay, fine. So, whenever you are watching the session, just give me your feedback. F of x is equal to 3x minus 8. If x is less than or equal to 5. So, x is less than or equal to 5, you have one function. X is greater than 5, you have another function. So, you want to check whether the function is continuous or not. Actually, no. In this, their function is continuous, it is given. So, you are looking for k value. Getting my point? The function is continuous everywhere. So, if you see the breakpoint here, so there also the function is continuous. Since the function is continuous, I can say that limit x approaching to 5 f of x is actually equals to f of 5. So, I'm going to look at the limit. So, the limit x approaching to 5 f of x exists since the function is continuous. Since the function is continuous, limit x approaching to 5. Limit x approaching to 5. F of x, how can I find this? So we have to find LHL and RHL. Why? Because at x is equal to 5, left side if you see it takes different value. Right side it takes different function. So what is LHL? Limit x approaching to 5 minus f of x is equal to. So when x is less than 5, the function takes this value. So the limit x approaching to 5 minus 3x minus 8. So substitute x is equal to 5 there. 3 5s are 15, 15 minus 8. So it is 2, 5, 7. So if I look at this, limit x approaching to 5 plus f of x, which is equal to, so here x value is greater than 5. So the function takes this limit x approaching to 5 plus 2k. It is actually constant. There is no x value. So it will give 2k as the answer. So since limit exists, LHL and RHL are equal. So this implies that 7 and 2k are equal. So what is the value of k? K is 7 by 2. That's how you find the answer. I hope you understood, right? So the answer is option B. So this question is from KCET 2015. So it's very simple. Board level only, right? Yes. Let's move on to the next question. Yeah. So for this question, you need to know what? Limit. So limit concept is needed here. Yes, guys? Fine. Since the function is continuous at x is equal to 0. So what is the first thing you do? Limit x approaching to 0. F of x is equal to f of 0. This is true. So I can say from this definition, given that f of 0 is equal to 1 by 2. It is very clear. So now we are looking for limit x approaching to 0 f of x. So I can say the limit x approaching to 0. It is not a stepwise function. So I can replace f of x by 1 minus cos kx divided by x sin x. So whenever you see 1 minus cos kx, so you want to use the formula. So one trigonometric formula is there, what it is. So if you know the formula, put it in the comment. If you know the formula, put it in the comment. So I will give you the clue also. 1 minus cos 2x is equal to 2 sin square x, no? Right? So here I have 1 minus cos kx. So that can be written as 2 sin square. So whatever it is, kx divided by 2. You get. Right? So this is the formula that we are going to use here. Okay? Great. So, yeah. And also we have 1 minute. Okay. Fine. So you can use this formula or we can use here if you see. Okay. So I can make it much more simple, guys. So I can make it much more simple. Look. Here I have 1 minus cos kx divided by x. In denominator you have sin x. So I know that from limit x approaching to 0 sin x by x is actually equal to 1. Right? So in denominator I find sin x. If I have x in the denominator, I can make it. So limit x approaching to 0, 1 minus cos kx divided by. So I multiplied x, I divided x. X square sin x divided by x. So now I can say that limit x approaching to 0. So this limit will become 1. So I have 1 minus cos kx divided by x square. So this one I have, right? Fine. So now I'm going to use the formula. So the formula is very simple that you already know. 1 minus cos x, you aware of this. 2 sin square x by 2. So since I have k here, I have to put k here also. So we are using that 2 sin square. So I forgot the limit, na? Let me write that. Okay. So let's write limit x approaching to 0, 2 sine square x by 2 divided by x square. Okay, I have k also. Fine, done. So here I have anyway this thing. Sine, okay. So anyway, if you see limit x approaching to 0, 2 into sine kx by 2 the whole square. So in denominator I have square. If I have kx by 2 in the denominator, that kx by 2 the whole square. What I have done here? So here I have x square. So here I have kx by 2 the whole square. K square by 2 square I multiplied in the denominator. So actually I divided k square by 4. So I have to multiply k square by 4, right? Yes. So now if you see 2 and this thing get cancelled. I got k square by 2 which is constant I took out of the limit. Limit x approaching to 0 sine kx by 2 divided by kx by 2 the whole square. So which is equal to k square divided by 2. Anyway, limit x approaching to 0 sine kx by 2 divided by kx by 2 the whole square. So this is why I told you you have to learn limits. So this value is going to be 1 only, no? So we know that limit x approaching to 0 sine x by x. So sine x, whatever here it should be equal to 0. So approaches to 0. Sine x by x, that is equals to 0. So here also we are having this function tending to 0. So it is equals to 1. So finally I got here that your limit. So k square by 2 as the limit value, right? So that must be equal to what? F of 0. So I know that this is true, no? I got this value as k square by 2. This is 1 by 2. So then k square is equal to 1. K is equal to plus or minus 1. So do we have the option? Yeah. So here is the answer. So this is 2020 KCET question. This is also kind of easy, right? So if you know the limit concept, you can easily solve this. Correct? Fine. So moving on to the next question. I think this question we already done. Okay. So now we are going to see one concept, one important concept. That is in continuity. So if f and g be two real function continuous at the real number c. So at c belongs to d. So the function f is continuous, f and g is continuous. Then I can say that algebra of f of g, algebra of functions, f plus g is also continuous. At that particular point x is equal to c. So similarly, f minus g is also continuous at x plus c. So f into g is also continuous. F by g is also continuous. For example, f is equal to x square is continuous at x is equal to 0. Similarly, I can say that g is equal to g of x, f of x, 2x. So this is also continuous at x is equal to 0. I can say that from this property, f plus g of x, which is nothing but adding these two, x square plus 2x. So that is also continuous at x is equal to 0. Why? Because I know that it is continuous. f of x is equal to x square is continuous at x is equal to 0. If g of x is equal to 2x is continuous at x is equal to 0, the sum of these two are also continuous at x is equal to 0. Even if it is minus, it is continuous. It is product, is it continuous? And also in division, it is continuous. But converse is not true. So remember, converse is not true. Got it? So if I say some function sin x by x, so is continuous at some function, continuous at some point. I can't say these two separate functions are continuous at that particular point. Okay, so the converse is not true, but this is true. Okay, fine. Okay, let's solve next question. Suppose f and g are, it's not, okay, it is also a theorem. So it's important theorem. Theorem 2. Suppose f and g are real valid function, such as f composition function. So you know what is f composition. So if that is defined, you want to check whether it is defined at that particular point or not. If it is defined at x is equal to c, then or you want to check if g is continuous. G is continuous at c and f is continuous at g of c, then f composition g is continuous at c. So this statement you no need to memorize, you understand. So what is f composition g? F composition g of x is nothing but f of g of x, g of c, g of x actually. So you here the function f and g are continuous at x is equal to c, and also you want to check f composition g is defined at c. So we are checking for the function whether it is continuous at x is equal to c. What to do here? F of f composition of g of x is nothing but f of g of x. G of x takes input from the input, that is x is equal to c. So here c goes to g, so it will give g of c as the output. So now f is the function, takes the input as output of g, right? So this value is the input for f now. So then you are getting output. So in this scenario, f should be the function, should be continuous at g of c. So then only f composition g is continuous at c. So you need to check these two. So since g is taking the input c, so you want to check whether g is continuous at c. So f taking input from g of c, so you want to check whether it is continuous at that particular point. So f composition g is continuous at c. So this is one of the important property. Okay. So now I am going to discuss one topic. So discontinuity. So you already know what is discontinuity, right? So there are types of discontinuity. So one is removable discontinuity, another one is irremovable discontinuity. So what is the difference of these two? How to figure it out? That we will discuss. So maybe in NCERT you don't have it. So but this is very basic, guys. So types of discontinuity. You have removable discontinuity, irremovable discontinuity. So removable discontinuity, irremovable discontinuity. What is the difference? So removable discontinuity means, 1 minute. Okay. So what is removable discontinuity? Discontinuous there, but if we try a little, if we give a particular value, then it for that particular discontinuous function, it will become continuous. Removable discontinuity is nothing but if you have this condition, the limit x approaches to first condition you want to look for, limit x approaching to particular value a. If here, if x is equal to a is point of discontinuity. Discontinuity. So for example, if you have a graph at x is equal to a, the function is discontinuous. Okay. Then that discontinuous point can be distinguished as removable, irremovable. When it is removable, when you find limit x approaching to a, f of x exists, this value is existing, and f of a is also exist, but f of a is not equal to limit x approaching to a f of x. So the limit x approaching to a, the particular discontinuous point, it exists, the limit value exists. Left hand limit, right hand limit, both are equal, limit exists. F of a value is also something, but okay, if these two are not equal, or this particular f of a value, we can say whether it is exist, finite or infinite, that doesn't matter. If it is finite or exist or infinite, it doesn't matter. Okay, but if f of a we have, so if these two are not equal, if limit exists, then it is removable discontinuity. If limit doesn't exist, if limit x approaching to a f of x doesn't exist, so then it is irremovable discontinuity. So how to figure out? So in graph, it is very simple. So if I have function like this, if I have hole in between, okay, so this particular area A, okay, so I have a dot here, which means, so let this be L1, let this be L2. In this particular graph, I can say that limit x approaching to a, f of x is equals to left hand limit, right hand limit is approaching to L2. L2. So what is f of a is equal to L1. So these two values are not equal. Then I can say the limit at this particular point a is removable discontinuity. Why it is removable? We can define a function in such a way f of x is equal to, okay, so f of x, if x is not equal to a, at x is equal to a is the problem. If I get x is equal to a as f of a, so f of a here I have a value, no? If I get that f of a only, so then you will be getting the value. So not f of a, you can write like this, the limit value. So the limit x approaching to a f of x. So whatever the limit x approaching to a f of x, that value you are getting, if that is for x is equal to a, if x is equal to a, f of x is giving the limit value, then problem solved, you know. According to the definition, limit x approaching to a f of x actually equals to f of a. So I can say the function is continuous. So I can remove the discontinuity by redefining the function. So that is why this is removable discontinuity. So what is irremovable discontinuity? If limit x approaching to a, f of x doesn't exist, LHL, RHL are not equal, then I can say that it is irremovable discontinuity. This discontinuity you can't redefine and make it continuous. You can't remove that. So the function which jumps, So this type of functions are called as irremovable discontinuity. This type of function is discontinuous and this particular point is irremovable discontinuity. I hope you guys understood. Hello, hi. Okay. Find all point of discontinuous of function of this function. So let me take you through this question. Look. So first, let us make it very simple. This function, when x is less than 2, it is continuous everywhere. At x is greater than 2, it is also continuous because it is linear function. So the end point is x is equal to 2. So we need to check. We need to check at x is equal to 2 only. Right? So the limit x approaching to f of x I need to find. So we are looking for LHL and RHL. So what is LHL? Limit x approaching to 2 minus f of x is equal to limit x approaching to 2 minus the value of x is less than 2. So you will be getting 2x plus 3. So which means when I substitute 2 here, 2 2s are 4, 4x, 4 plus 3, it is 7. So what is RHL? Limit x approaching to 2 plus f of x, which is equal to limit x approaching to 2 plus 2x minus 3. When I substitute the value, 4 minus 3 is 1, so 1. LHL, RHL are not equal. So x is equal to 2 is point of discontinuity. And you know about what type of discontinuity it is. Since LHL, RHL equal, limit doesn't exist. I can say it is irremovable discontinuity. Irremovable discontinuity. So I hope you understood what is irremovable discontinuity. If you understood this concept, irremovable and removable discontinuity, so then you are in the right path of solving questions. So if you understood, give me a thumbs up. And if you are still confused, then try to post it in the comment where you went wrong. What is the difficulty? Okay. Okay, come to this. F of x is equal to mod x plus 3 if x is less than or equal to minus 3. F of x is equal to minus 2x if this is in that interval. So here if you see, you want to redefine the function. Let me clear the space and give you the clear idea about the picture. So why it become really very small? Okay. Look. Okay. So here, since x is less than or equal to minus 3. So if x is negative, it will become minus x only, no? Let's redefine the function. So this is, since here all value of x is negative only, so I can write minus x plus 3. So here minus 2x, so this is. So since here you have a function as minus x plus 3. When x is less than or equal to minus 3, everywhere it is continuous because it is linear function. Here also it is linear. In this interval, it is continuous. In this interval, it is continuous when x is greater than 3. So coming to a point. So the break point. At x is equal to minus 3. At x is equal to 3. How the function behaves, that you need to check. Because at x is equal to minus 3, left side of this function, it takes different value. different function. Right side, it takes different function. So let's figure out. So we have 2 points at x is equal to minus 3 and 3. You need to check. Limit x is equal to x of minus 3, f of x. So you want to check for LHL and RHL. So I'm going to find LHL. Limit x is approaching to minus 3 minus. Since x is less than minus 3, so it takes this function. Minus x plus 3. So when I substitute x is equal to minus 3, minus of minus 3 will become plus 3. 3 plus 3 is 6. So when I substitute limit x approaching to minus 3 plus. So here I have minus 2x, which is equal to, when I substitute minus 3 here, minus of minus plus 6. So here LHL, RHL are equal. LHL, RHL, both are equal. Limit exists. So the limit x approaching to minus 3, f of x is equal to 6. So what about f of minus 3? So where is equal to sign? Here is no. So I know it is also equal to 6. So fine. So it is continuous at x is equal to 3. At x is equal to minus 3, it is continuous. At x is equal to 3, at x is equal to minus 3, it is continuous. Okay. So then we are going to see for x is equal to plus 3 as well. Give me a sec, let me erase this. Okay. So at x is equal to plus 3, LHL, RHL. So what is LHL? RHL. So LHL, limit x approaching to 3 minus. So what is f of x? Modulus of x plus 3. So modulus of x plus 3. Limit x approaching to 3 plus mod. Here it is. Wait a sec. I am looking for 3. No? Sorry. Okay. So 3 plus. Okay. So the value which is less than 3. This particular function minus 2x. When x value is greater than 3, 6x plus 2. When I substitute 3 here, so minus 2, 2 3s are 6, minus 6. When I substitute 3 here, 6 3s are 18, 18 plus 2 is 20. LHL not equal to RHL. So I can say that the limit x approaching to 3 f of x is not equal to, doesn't exist. It doesn't exist. So x is equal to 3 is the point of discontinuity. So and you know what is this type? So even limit doesn't exist, which means it is irremovable discontinuity. Okay, I hope you understood. So yeah, so these are all the questions from your book. So better try to solve all these questions. So these questions are as like as the previous one what we discussed. So better try to solve this. Okay. This type of question they ask often in KCET and also board. Better try to have a good hands-on practice in this particular type of questions. Let's solve this. So here it is given the function is continuous at x is equal to 0. Since the function is continuous at x is equal to 0, so the limit x approaching to 0 f of x. It is continuous at x is equal to 0, I have to put this. No need to think anything. So what is f of 0? So when I substitute 0 here, it becomes 0 only. Right? Fine. So what about the, okay. So the limit x approaches to 0, f of x, you want to fix LHL and RHL. So what is limit x approaching to 0 minus? X approaching to 0 minus f of x. So when it is minus, it is lambda, no? Okay. So the lambda x square minus, I'm directly substituting that. Okay. So when x is equal to 0, the value is 0. Leave it. The limit x approaching to 0 plus. Okay. So they asking about 4x plus 1, which is when I substitute 0 here, I will be getting 1. So the function, if it is continuous, these two must be equal. No. If I check here, RHL, LHL is not equal. So they're asking about for what value of lambda, the function is continuous. Whatever the lambda value, here the LHL and RHL are not equal. So whatever the value of lambda, LHL and RHL are not equal. No, the function is not continuous. The function is, limit does not exist. Limit doesn't exist. Limit doesn't exist. So I can say that the function is not continuous. Not continuous at x is equal to 0. Whatever value of lambda it is not continuous. Getting my point? So now they are asking about the continuity at x is equal to 1. So what is x is equal to 1 first of all? So x is equal to 1 means, so the value which is greater than 0. So the value which is greater than 0, we are looking at the limit. So the limit, we are looking for limit x approaching to 1 f of x. So f of x has to be replaced by 4x plus 1. Put x is equal to 1. So 4 plus 1 will become 5. So the limit value is actually 5. You got the answer. What about f of 1? So f of 1 also in the same, it's the same function. So you will be getting 5 as the answer. So limit and f of 1 is equal. I can say the function is continuous at x is equal to 1. Getting my point? Yes. So now here we are going to find the relationship between a and b so that the function f defined by f of x is equal to this. So look, here if you see f of x is equal to this, you want to find the relationship between a and b. It is given that function is continuous. So here it is given. So what is given? F of x is continuous at x is equal to 3. Limit x approaching to 3, f of x is equal to f of 3, it is given. So what is limit x approaching to 3? So you have LHL and RHL. So I know f of 3 is actually equals to 3a plus 1. Let it be. So now I am going to look at the limit. So the limit x approaching to 3 f of x. If I look, so when x is less than 0, it takes one function. When x is greater than 3, it takes another function. So I have LHL and RHL. So what is LHL? Limit x approaching to 3 minus. So f of x. So since 3 is less than, since x is less than 3, so you want to put ax plus 1. So when I substitute 3 here, 3a plus 1 I get. So similarly, limit x approaching to 3 plus bx plus 3. So you will be getting 3b plus 3. X is equal to 3, 3b plus 3. So LHL and RHL are equal. So LHL 3a plus 1 is equal to 3b plus 3. So you will be getting 3a minus 3b is equal to 3 minus 1. So 3a minus 3b is equal to 2 is the relation. So I can write, you can divide by 3. A minus b is equal to 2 by 3. Okay. Fine. So a minus b or a is equal to 2 by 3 plus b. So this is the answer. So we found the relationship between a and b. Got it? Yes. A is bigger than b actually. So b plus 2 by 3 is a. That's the relation. So moving on to the next question. So here is one of the important question. Mostly I don't know why. Whenever I go for correction, no. If this particular question is as in question paper, most of the students using different method. I don't know why they are doing that. So what method you find here? Limit x approaching to 0. So here you have x square sine 1 by x. So most students using this by limit x approaches to 0 sin x by x format. So but what is the use of using that here? So whenever the x input takes to 0, denominator also equals to 0. You have to look into it. So here limit x approaching to 0, 1 by x here it is. When x is approaching to 0, when it is approaching from left side, it will become minus infinity. When it approaches from right side, it will become plus infinity. You can't do using this particular formula, right? So in this limit is not possible. Then what is possible? Limit x approaching to 0 sine 1 by x divided by 1 by x squared. So you can't do in this way. So then what can be done? So we are going to use one method that you already studied in 11th standard, which is sandwich theorem, also known as squeezing principle. So what is sandwich theorem? So I'm going to write the definition of sandwich theorem. If a function f of x and g of x lies between h of x, okay, so it's less than or equal, less than I can put. Less than or equal to, no issue in that, okay. So in the main idea is g of x and f of x will be the boundary, like maximum and minimum for the function h of x in the domain. In the domain, like a comma b, I can take anything, okay. So or domain D, fine. So in the domain D, I have the function f of x, g of x, h of x in the satisfying this condition, okay. So now what is, I am looking for the limit of x approaching to a h of x, but this is not that easy to find. But I can find if limit x approaching to a f of x, not a, like c I can write. So what is c actually? C belongs to the domain a comma b, okay. So and limit x approaching to c g of x. If both are equal, if both the things are equal and both are equal to L, I say both are equal to L. So then automatically by sandwich theorem, I can say that by sandwich theorem, I can say that limit x approaching to c, h of x is also equal to L. So the proof is very simple. Since the function f of x, g of x and f of x something looks like this. So why I have a touch point here? So this point is C. I told that the limit are equal. So that limit point here, the corresponding value is L. So you want to understand this clearly. Got it? G of x. So this is f of x. In between you find. This is your h of x. Okay. So if h of x is between f of x and g of x and limit x approaches to c f of x is equal to limit x approaches to c g of x. So then you can say that this is also equal to L. So now here I have sine function. Sine 1 by x will be between -1 to +1. So here when I multiply x square, so being x square is a positive number, if I multiply, the inequality sign will not get changed. So minus x square less than or equal to x squared. Sin 1 by x is less than or equal to x squared. So now I am going to use the limit. Limit x approaches to 0, right? Minus x square less than or equal to x square, limit x square. So I'm going to find the limit value. Let me figure out first. So anyway, this is equals to 0 now. It is equal to 0. Similarly, limit x approaching to 0, x square is equal to 0. So both the limit value x approaching to 0 is 0. So then this also automatically will become limit x approaching to 0, x square sin 1 by x is also equals to 0. Got it? So this is how you solve this question. Fine? Okay. So I hope you guys understood. So in this is going to be the last question for the session. So this question, if you know the limits well, you easily solve it. Here at x is equal to pi by 2, you need to check. So how to do it? Limit x approaching to pi by 2. So f of x. So no need to do LHL or HL and all, because at x is not equal to 0, this function satisfies. Limit x approaching to pi by 2. K into cos x divided by pi minus 2x. So here I have x approaching to pi by 2. So I am going to introduce the variable y, which is equal to pi by 2 minus x, which makes when x is approaching to pi by 2, y will be approaching to 0, right? So here we are going to use that. So the limit y, I am going to change the variable x to y, since here y is approaching to 0. K into x has to be replaced by cos into x has to be replaced by pi by 2 minus y, right? Yes, divided by, so pi minus 2 into x has to be replaced by pi by 2 minus y. Okay. So next step, limit y approaches to 0, k into, this will become sin y divided by pi minus 2 to get cancelled, minus pi plus pi minus pi minus pi plus 2 pi plus 2y, which is equal to limit y approaches to 0, k into sin y divided by 2y. So you can write k by 2 outside, limit y approaches to 0, sin y by y. So what is sin y by y? So limit y approaches to 0, sin y by y is 1. So your value is k by 2. So here I want to substitute the value of k. Sorry, I want to find the value of k. So the function is continuous at x is equal to pi by 2. I can write limit x approaching to pi by 2, f of x actually equals to f of pi by 2. So I know f of pi by 2 is equal to f of pi by 2. So this is equal to 3. It is given in the question. K by 2. So k value is equal to 6. So this is how you solve this question. Okay. So yeah, coming to the end of the session, I think most of this wait a sec. Yeah. So let's come to the end of the session. So what are things we discussed in today's session? So we discussed about continuity. What is continuity of a function at a particular point? So what is continuous function on a domain? Then we discussed about discontinuity. So we have 3 types of discontinuity. So one view where you find breakpoint, hole you have, so then jump. So in discontinuity, we studied 2 different types. One is removable discontinuity, irremovable discontinuity. And then we solve some questions from your book, right? So, and we discussed some questions from KCET also. I think you have a proper understanding about limit and continuity, right? So you solve questions from the exercise. So you have very good questions in your book. Better try to solve the questions first. Understand the basics. If you understand the basics only, you can move on to KCET. So, and solve KCET questions. You want slightly more interesting and tough questions, you can approach JEE questions also. You find very good questions in that. Try to have a hands-on practice in that. If you find any question different or difficult, you just put it in the comment box. If I will keep on looking in your comment, looking at the comments. If that question should be addressed in the session. So next session, I will be teaching you that question. I hope this session is helpful for you guys. Next session, what you want. So this is the part 1 video. Next session, we will be discussing about differentiability, and in continuity, we have some more questions to discuss. So that question we will discuss, and some more questions from JEE point of view also I will take and come for your better practice. Next session, we will be discussing differentiability. So what is your point? What is your comment about the session? You put the comments in the comment box. So stay tuned. See you all in the next interesting session. I hope you all enjoy the session. Thank you all. See you in the next session. Bye.